Alright guys, Midwest Cam back at it again, and we're going to do dimethyl carbonate this time. We're going to do this by transesterification of propylene carbonate, which I've synthesized, and we will show you that in a moment. For now, we have our anhydrous methanol, about 350 mils. I'm only using about half of what I should, but according to the paper I'm going to, they had a 10 times molar excess, which I find probably be, that's probably good. I'll probably top it off with some more ethanol, because what I'm going to do is take the propylene carbonate, throw it in here, and these molecular sieves I went way overboard with. There was hardly any water in that methanol. So I'm going to go ahead and dump everything in here, top it with a little methanol, propylene carbonate, and let it all dehydrate as much as possible overnight. I'm preparing this, but today we're also going to prepare the catalyst. This is calcium carbonate. We're going to throw that in this guy right here. I'm going to clean this out here in a sec, but this is going to be my vessel to make calcium oxide. So we'll go ahead and get to the propylene carbonate. Alright guys, sorry, I accidentally put the propylene carbonate in before I got to record it, but down here, this oily substance is propylene carbonate, and I've dumped it into the methanol. We have the molecular sieves that will dehydrate this as much as possible. Dumping it in, I noticed the dissolution of propylene carbonate and methanol is endothermic, so got a bit cooler. So anyways, now off to make the calcium oxide. Alright y'all, so I had some struggles deciding what to use for the catalyst. So I think the best route we're going to go is sodium hydroxide. Easy peasy catalyst. And I may throw a little calcium oxide, because that's also a heterogeneous catalyst versus the NaOH that is a homogeneous catalyst. So we're going to go ahead with this. We'll add this up and I'll get the rest in. Cool. So we have our unfortunate little molecular sieves in there. Poor things aren't going to be good for long. And we have this double-sided adapter stacked to kind of make a makeshift. Oh god, it's the Vigru column, I think. Correct me if I'm wrong. I'm going off memory and lack of sleep. So we're gonna go up here. Got our condenser and a drying tube with some magnesium sulfate in it. There we go. Right. So we're gonna add some NaOH to this, and I do believe, since my NaOH is the monohydrate, we're gonna go ahead and add a little bit of calcium oxide to the mix, because calcium oxide is a catalyst also. This is a heterogeneous catalyst. This is a homogeneous catalyst. This will dissolve and become part of the mixture. This will not. But I'm thinking that adding just a touch of this will help absorb the water and prevent more moisture from getting in and all that. So we're going to go ahead, load it up, and see where this takes us. Oof. Temporary. So while we're at it, 63.4, I believe, is the methanol dimethyl carbonate azeotrope, and that's what we're going to collect. So, very strange we have it all the way up here so far, so I guess that's probably the azeotrope, because it's pretty warm down there. So, but that's also why I extended the column, so. Concerning. Okay. Might be from the ice I just added, but we've got a few drops, and it definitely is not methanol or propylene carbonate. It's got more of a solventy smell to it. Very exciting though. Steady held about 63, the azeotrope temperature. We're starting to get an okay flow rate. Very slow, but hey, whatever. Alright, looks like we are hitting the end, I suppose. It's dropping. So we got a little bit there, a little bit there. Definitely gonna be a load. Lesson learned, sodium hydroxide sucks as a transesterification catalyst. So we have sodium dissolving in methanol to make sodium methoxide. This is going to be our catalyst. We're going to try a 1 molar scale again, and hopefully we'll have some dimethyl carbonate production. So nothing too interesting to report on yet. The sodium dissolved swimmingly, very easily, very quick. 300 milliliters dissolved 1.5 grams in about 20 minutes. So got that. It's going to be heating up, and then we got our condenser here. Now all this crap is on the side of the flask, not inside. And then we got a drying tube with freshly charged molecular sieves, and my scale that's looking really sad.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it.
Alright, here we go. So, looks like it's gone a little cloudy. It is starting to reflux. It says reflux for 10 minutes at 70 C, so we're going straight for distillation, hoping the difference in time and temperature will be made up. Transesterification catalyst has been made, and we're just waiting. There are some bubbles. I'm hoping that's boiling, slight boiling, and not catalyst destroying or product destroyed. So I guess we'll see. And rapidly it climbed, which makes me think a volatile fraction. It's more volatile than methanol came. Getting some pretty good boiling. Building up, and we'll get some drops soon. here we go. I just switched over. We have a thick, milky, boiling flask. And then we have this. It's not coming fast, but it's pure. Alright, cool. Looks like I got about 10 mils, maybe 12 grams. And, yeah. Probably should have used a fractionation column. Would have got better results. So, maybe that's what I'll do with the next 2 bottles. But, I just really wanted to finish this video and have a pure sample. So, there we go. Pure dimethyl carbonate.